Hello everybody, my name is Frank José Afonso. I prepared this video presentation to attend the SEKE conference. I will present the paper DmS-Modeler, a tool for modeling decision-making system for self-adaptive software domain. Gustavo Leite and Elisa Nakagawa are the other authors of this paper. Here are the main topics of this presentation. First of all, I will present an introduction about this paper context. Next, I will present an overview about the reference architecture for self-adaptive software and the framework for decision-making in self-adaptive software. Details regarding the design of our tool and the case study developed to validate it are presented in the next topics. Finally, I will present the conclusion of these papers. Introduction. Software systems have played an important role in the modern society. Self-adaptive software SaaS presents specific features compared to traditional ones. Why? This type of software requires adaptations at runtime. Software adaptation, when manually performed, becomes onerous regarding time, effort, and money, and it can be error-prone activity by involuntary injection of uncertainties by developers. As a solution, automated approaches. This type of approach has been adopted as a feasible alternative to maximize the speed of SaaS implementation and at the same time minimize the developer's involvement. If we have a self-adaptive software as an important type of software, on the other hand, we have a reference architecture, a special type of software architecture that have become an important element to systematically reuse architectural knowledge. This type of architecture tends to contribute significantly to the design of concrete architectures for new systems, the extension of systems of neighbor domains of a reference architecture, the evolution of systems that were derived from a reference architecture, and the improvement in the standardization and interoperability of different systems. In previous work, a reference architecture for self-adaptive software was developed, and as part of this reference architecture, a framework for decision-making was developed too. The main purpose of this framework is to identify anomalies and propose one or more solutions to solve them. Although our reference architecture and our framework have improved in the SaaS development, the design of the decision-making system DMS was still manually conducted. It is not good. Based on this scenario, a tool named the DmS-Modeler was developed to support the decision-making system development for SaaS context. After this overview, now I will present a brief description of our reference architecture, a reference architecture for self-adaptive software. Here we have a general representation of our reference architecture. As can be observed in this figure, this architecture is composed of 4 external models and a core for adaptation, dotted line. This core represents an automated process for adaptation of the software entities at runtime. Here we have a general view of the process of adaptation. Our reference architecture uses an external approach of adaptation. This approach is organized in 2 levels, meta and base. The meta level represents a supervisor system, which contains the logic for adaptation, and the base level represents the supervised system, which can define the adaptable software. This type of software is called as software entities or simple entities in our reference architecture. So, our reference architecture works with a controlled adaptation approach. For this, the software engineer must insert annotations from annotation model in each software entity so that the automatic mechanisms of our reference architecture can identify the adaptability level of each entity. These levels aims to determine where the new change may be applied. So, for adaptation, our reference architecture has an automated process. This process is composed of 9 steps, can be observed in this figure. The process involved by red line represents our framework that will be detailed in the next slides. Now I will present a brief description of this framework. This framework acts as a non-intrusive supervision modality based on external approach. Here we have a meta level and a base level. So we have a supervised system in meta level. This system can be coupled to a software entity in the base level to monitor its internal state or of operation or changes in the execution environment. Our framework has 3 modules: a classification of problem, a recommendation of solutions, and a test of solutions. Concerning the design, the MAPK loop and the learning techniques were the resources used in the design of this framework. The loop is represented by the models and the other components in this figure. The learning techniques, incremental classifier, the rules association, are being used in each model, classification model and the recommendation model, respectively. Now, I will show some details about the classification model. For this model, the software engineers must specify the application domain, mapping the main points of a software entity that will be monitored. In other words, the data collected from sensors. This specification details the number of attributes of an instance and the values that be assigned to them. There is a class. Details of each component of this model can be found in our paper. As output, this model provides an incremental classifier. Here we have a classification of a problem. Next, we have a similar infrastructure for the recommendation model. As output, we have a rule set. This model provides a set of rules, which they sorted by statistical measures. Now I will present the main components of our tool. As I said, DmS-Modeler was developed to support the decision-making system developed for SaaS contexts. Here, in red dotted line, we have the infrastructure of our framework that I explained in previous slides. This infrastructure is similar to the previous ones. In short, this model is responsible for mapping a solution in source code to be inserted in the execution environment. In short, the DmS-Modeler can be defined as a front end for our framework. Now I will present our case study developed to validate our tools. So, to evaluate the applicability strengths and the weakness of our tool, a case study was conducted. As a subject application for our empirical analysis, we have selected an application addressed to UAV in a simulated environment. Here we have the architecture for our case study. This architecture is composed of 3 layers: UAV, communication process, and the clients. Each UAV is equipped with 7 sensors, which being observed in this list. Okay. Now I will show the process for modeling a DmS-Modeler. Here the user provided information for creating a project. The user provided a name project, a database name, and a description for a project. Now we have a discretization process. Here, this process is very important for our tools because the algorithms used in our framework or in our tools requires nominal values. So here we have a discretization of variables for battery sensor. This table shows how the values were labeled in class. After the discretization process, the modeling activity must be started. Each sensor will be transformed into an attribute and its class in values for these attributes. Sorry. Then this process can be seen in our tool. Here we can see the attributes and their values. In this interface, we can observe that the last attribute represents the class for the problem, red dotted lines. As initial knowledge, the user must provide a knowledge for both models. Blue dotted line for the classification model and the suggestion of solutions for problems mapped by the classification model are represented by the red dotted line. Here we have a small set of rules for our case study. Finally, conclusions. This paper presented the DmS-Modeler tool that intends to support the SaaS development. This tool incorporates a framework for decision making, and we believe that the benefits of our tool can also extend for other communities of software development. Based on this scenario, the main contributions of this paper can be highlighted for the SaaS area by providing a means for development of a DmS-Modeler decision-making system. For the use of our framework, provided a wizard for modeling of such system. So that is all. For further information, you can contact him by email. Okay, bye.